Welcome to week one, Introduction to Object-Oriented Programming using Java. Uh, in this week one, we're not going to be doing any coding. We'll basically be looking at the concepts of object-oriented programming. By the end of this week, the expectation is that you will be able to explain what object-oriented programming is, OOP, and why it's useful. And we'll kind of give an introduction to four core concepts of object-oriented programming. It's encapsulation, abstraction, inheritance, and polymorphism. Also want you to be able to distinguish between regular procedural programming and object-oriented programming. And then finally, in general, conceptually define what a class and what an object is, kind of leading into or jumping into the deep end of the pool for object-oriented programming. Then, read, understand simple Java class structure. Okay, not yet writing code, but just from an introductory perspective. Okay, so what is object-oriented programming? Object-oriented programming is a way of designing software, modeling real-world things. Okay, real-world objects. Okay. Each object that we're going to be talking about and creating has data or attributes associated with it, and then methods, what that object can do or will do. Real world analogy, think of a student. Okay, we have a student having a name, major, and GPA, and there's certain behaviors that we're expecting from the student, things that this particular object can do. For example, register for class or print bio. Again, you will be defining what both the attributes and the methods are for your particular projects. Okay, why use object-oriented programming? Object-oriented programming helps us manage large programs, reuse code instead of rewriting it. I can be using an object in several places, make programs easier to maintain and to extend, and model real-world problems naturally. Okay, since we're talking about real-world objects, then we're basically be looking at solutions that are that come natural, okay, in our association with things that happen day to day. Okay, Java in the language itself is basically from the ground up when Java was supported. It had in mind object-oriented programming. So it is not that Java kind of came in on the back end of object-oriented programming. From the ground up in its creation, it supported or was built to support object-oriented programming. Okay, procedural versus object-oriented programming. From a procedural perspective, procedural focuses on functions. Data is separated from the logic. Okay, it's harder to scale. An example is C programming language. So in this particular case, what we're saying is object-oriented programming takes a different approach. It focuses on the objects, and the data and the logic are combined. Okay, easier to scale. An example again is Java itself that was built specifically to handle or to delve into the world of object-oriented programming. The core object-oriented programming concepts, encapsulation, keeping data protected inside an object, access through methods, not directly. Okay, so we're not going in and writing the code for a bio. We are actually, but for someone who is using that object, okay, they're not concerned with specifically how we did it. They specifically want to know what results can I get from it. Okay, so that's the encapsulation, basically encapsulating or keeping inside all the internals of how we get things done and basically providing an answer, okay, based on when that object is called. Abstraction, showing what an object does, hiding how it does it. You drive a car without knowing how the engine works. Okay, that's the abstraction, okay, with the object. Real world, okay, but we're not really delving into the internals, we're delving in the results. Inheritance, creating new classes based on existing ones. This is basically say I may not have as an object, may not have the ability to do something. But in this case, I can inherit, say, from a child of mine. They may do something specific. Whatever that child does, I can bring up, and I can also do it. I can inherit that. I can inherit that functionality, and so that's what we're describing here. Creating new classes based on existing ones. Okay, promotes reuse and organization. For example, I could have a graduate student who is a student. Okay, and I can, based on that, I could have functionality as a graduate student, okay, that can be inherited, or I might inherit something from the student itself. Polymorphism. Same action, different behavior. Objects can respond differently in the same method call. Example, if I'm printing a bio, I might print different results for different student types, graduate students, for example. Okay, so polymorphism basically says that I can get different results, okay, from calling the same object. Okay, poly, many. Okay, so that's just saying it's not a strict. Oh, here is my object. It can only do one thing. I can basically give it that capability to do multiple functions. Okay, so what is the class versus an object? Okay, class is a blueprint. Think of that. Think of a house. You have a blueprint of the house. So, you know, what's going to be in it, what the rooms are. Okay, and the object is the actual house. Okay, or the houses. I built a house on Main Street. I built a house on First Street. Okay, all using the same blueprint. Okay, so that's what a class is. A class is a blueprint, and then the object is the actual entity that comes from that blueprint. So here, class, blueprint, object, instance created from the blueprint. Again, looking at our student example, I create objects Alice, Bob, and Carlos. Okay, from that class or from that blueprint that we're just discussing. Okay, so that's kind of the overview. We're going to be delving into specifically starting deep in Java, kind of things that I'm expected that you would have already done at this point is basically set up VS Code and getting it kind of working as far as using Java. So that is where we're going to be from the concentration of this class. You may be able to use another VS Code type functionality or library. Okay. But we're going to be basically presenting examples based on VS Code. So instructions for that were sent out. And so hopefully if you're having problems, you would have already notified me. Please go ahead and do that. Also, as far as your projects, by the time you read, listen, or if you see this particular recording, would have already been assigned to you. So if not, let me know that you don't have a project and we'll come and get you set up there. And that shouldn't happen, but just in case. Okay, so let's take this as the introductory. That's another thing. A lot of what we're going to be doing on video is going to be of this type. It's going to be the introduction of the concept. And we will show you some functionality that you could use. But I've always had the opinion that, and especially in programming class, that you learn how to program by programming. Okay. Yeah, I can sit up here and tell you about a class and a student and an object, but until you actually use it and actually do it, okay, you won't pick up on it. Okay. So, my emphasis is going to be on programming. You will be programming a lot, okay, in this class. That is going to be my focus, okay, is that I'm going to present the concept, you jump in and you actually program it. Okay. So just keep that in mind. And so our videos are not going to be long, half hour, 45 minutes, because you're going to be using that half hour, 45 minutes to actually delve in and write some code as far as what we're talking about. Okay, so that's it for week one. Welcome to the introduction, week one. And we'll close it out now, and we'll see you in week two, where we'll be talking about specifically how we create classes and how we create objects and go to the next step. Okay, so everybody have a good one, and we'll see you later. Bye.